Howdy folks, we're going to be getting into our Exam 1 review for Math 120. So the first page was the outline of all the content for the exam, so now we're going to get into those problems. So let's take a look at the first one. So we have consider our different group of numbers here, and we want to list the ones that are in each of those different sets. So starting with the natural numbers, remember those are our counting numbers. So the only counting numbers in here looks like 12. Now we do have to be careful about square roots. Sometimes square roots can be natural numbers or whole numbers or integers. So we just have to be careful of those. Only those perfect squares though will fit that description. So let's start with just the 12. So now our whole numbers, remember, are all of the natural numbers, the counting numbers, plus 0 if it's in the list. And it is in the list, so we would add that to the 12. Integers, remember, are those negative counting numbers and the whole numbers. So we have a -4, and we still have the 0, and we still have the 12. So just those three. Next is the rational numbers. Remember, the rational numbers are fractions, anything that can be written as a fraction. So all of these previous numbers all can be written as a fraction if we just put them over 1. So all those would have to be included, plus any other ones from the list. So negative square root of 5, no go. We have a fraction here, -3/2, so that would be there. -0.5, remember, if it's a terminating decimal, then it can be written as a fraction. So that would also be in there as well. And then we got 4.1 as well. So we have to add those into our list. So now it doesn't have to be in numerical order, but I'm a math nerd, so I like to put them in numerical order. So once we get the rest of those, 0, 4.1, and 12. So looking good. All right, let's shift this up a little bit. And so next we have our irrational numbers. So pretty much anything you haven't listed yet should be irrational. So that would only be the negative square root of 5 and the square root of 3. Remember, it can't be in both of those groups. It's either rational or irrational. And last but not least are your real numbers. Now you can be lame and just put all, but in MyLab Math, it might ask you to list every single one of them. So you have to list all 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. So all 8 would have to be listed under the reals. So just be careful of the way they want it submitted. All right, moving on to the next one, some true false. So the absolute value of a number must be positive. Now this one is a little tricky because at first thought, your answer is probably going to be true. That's what you would probably think. But unfortunately, that is not correct because there's one number that screws it up. And what's that one number? That one number is going to be 0, because if you take the absolute value of 0, you get 0, but 0 is not positive. So this would have to be false. I know, it's kind of lame, but any other number would make it true. If they excluded 0 from that statement, it would be true. How about the next one? Absolute value of -7 equals the negative of -7. Well, if we simplify this down, absolute value of -7 should be 7. Again, there's no negative outside of the absolute value, so that means that it's got to be positive. Now the other side, -7, remember a double negative cancels things out, so that's going to have to be +7 as well, so that's going to have to be true. 2/5 is an example of a real number that is not an integer. Well, remember, if it's an integer, it has to be a positive or negative counting number or 0. Now 2/5, we can't reduce that to an integer or a rational or a whole number. I'll get it right. So in this case, the answer would be true as well. Every real number is either positive or negative. Well, we can kind of look at the first one. Remember, 0 is that one exception, so that means it's got to be false. All right. So now, let's get into these last two on this first page, and then we'll put the next page in the next video. So, order of operations. Now remember, biggest thing to be careful about is the order. And the first thing on the list should always be parentheses. Now, so we know we have to do the 9 minus 1, but the question is can we do anything else? And the answer is yes. Remember, if we go down the list, the next thing is exponents, and we do have an exponent here. And the other important piece is that it doesn't interfere with the first piece we highlighted. So we can do both of those at the same time, and it shouldn't be an issue. So we got 36, 6 times 6, minus the 4 times the 8. So now from here, we can't do this subtraction because order of operations says we need to multiply first. So multiplication would go next. So 36 minus 32, which we know is 4. So 4 should be the answer. All right, now this one, we got a few sets of parentheses. So we can do that set here. I like to put a little box around it. That way it just kind of highlights what you're simplifying. And on the bottom we can do this exponent. So negative 8 plus 3 better be a negative 5, minus 5 plus 10 is 15, all over, and 7 minus 9. All right, so far so good. A couple of subtractions and we're done. Negative 5 minus 15, so you're going further into the deficit. So that's going to have to put us at negative 20. 7 minus 9, well, easy way to think of these is to reverse it. If it makes more sense if you reverse the numbers, then probably the answer is just going to be the opposite of what you got. So let me explain. If we switch this around and said 9 minus 7, 9 minus 7 is 2. But by reversing those two numbers, it just changes the sign. So it's going to be a negative 2. And negative divided by negative better be positive. So we get a 10 for that answer, which is behind my head. So, all right. So that wraps up the first video, and hopefully you can hear this one. All right, we'll see you in the next video.